Let's talk about the difference between chemical and physical changes. Chemical changes involve the change in the substance identity. Remember, we call these also chemical reactions. Physical changes, the substance keeps its identity. Let's list some of each of these. For example, chemical changes would be burning, that's combining with oxygen, resting, fermenting, rotting, and digesting. Those are just a few examples, but you need to know these 5. Make sure you know these. Physical changes include a lot of phase changes, like boiling. Any phase change is a physical change. Freezing, because when you freeze water, it goes from being liquid water to being solid water, but it's still water. Also on this list we'll have dissolving. When you dissolve salt in water, it's still salt. So that's an important one to know because a lot of people don't realize that. Let's just say on here, any phase change is a physical change. Okay, so be sure you know those. And we can also define these in terms of properties. In other words, we can talk about the substance's tendency to undergo a change. So a chemical property tells about its tendency to have a chemical change, or the type of change it might have. So see what you can do with each of these. What type of property does each of these represent? Burns easily. Burning is a chemical reaction, so this defines a chemical property. Red color, that does not involve any chemical change or change in substance. That's just something that's observed. This is a physical property. Evaporates quickly. Evaporation is a physical change, so this is a physical property. Non-flammable, so this is its tendency to not react. So it's a chemical property. And conducts electricity. This one's interesting. If you have a copper wire and a current runs through it, is the copper still copper? It is. It retains its identity. So conducting a current is just a physical thing that happens. So this is a physical property. That one gets people. Be sure you know each of these for your test. Okay, next thing we're going to do is classify matter. This is kind of a standard thing you do in every chemistry class. You kind of categorize matter by the types of particles that it has. In other words, if we start up here with all types of matter, we could divide this into those things that are pure, and we call those substances, and those things that are mixtures. Okay, and then the pure substances, which by the way, that's kind of redundant because to a chemist a substance is pure. But anyway, the pure substances are either elements or compounds. The mixtures can either be homogeneous or heterogeneous. We'll get into those. Let's look at these. So the substances are pure. It means that if you could look at every single little molecule or particle, they would all be the same type. They only have one type of matter. And we said there are 2 types. They are the elements. An element cannot be broken down into a simpler substance by a chemical reaction or any other means. once you get into nuclear reactions, which we're not going to do yet. Okay, and then a compound has two or more elements that are chemically combined. So one of the questions I like to ask is, well, what is this? Many people will recognize that capital N is nitrogen, and this 2 means that there are 2 nitrogen atoms bonded together. So I'll just draw it like this. Is that an element or a compound? This is an element, because there's only one element present, nitrogen. In order to be a compound, you have to have 2 or more elements present. This is called nitric oxide, is the short name for this. Nitrogen oxide would be an IUPAC name. Anyway, so this one is a compound because there's 2 elements. Okay, our other type of matter was the mixture. Mixtures can be separated by physical means. There are 2 types. Homogeneous or homogeneous are 2 versions of the same word. But anyway, they are the same throughout. And solutions don't have to be liquids. A lot of times that's what we think about. But they can be solid, liquid, or gas. Like the air, you could say, is a solution of oxygen, nitrogen, and a few other substances. Heterogeneous means that you have distinct materials. In other words, like cottage cheese, Italian dressing, you can see different types of materials present.